Okay, so if you're good at memorizing things, it's a half sine 2x dx. So half out the front, change them to sine, and it's 2. So it's kind of like negative cos, and we divide by that. Plus c. There you go. I guess just writing that is enough working out, by the way. Possibly it might be good to actually show, like write the identity above that, to sine 2ax. That might be worth a mark. Eliminate powers. That's my kind of big hint to doing these. Eliminate the powers. So this is the same as cos x times by cos squared x dx. Does anyone have an idea what do you think I'm going to do with that? So I'm not going to use these three identities. Surprise! I'm going to use this identity. Mixing it up a bit. So, like I said, you may get a mark if you state an identity. So cos squared plus sine squared equals 1. So I'm going to rearrange that so cos squared is by itself. So left with 1 minus sine squared x dx. Okay, so you might be wondering, why did I do that? If you look at the sine squared x, can you see the derivative present? Squared cos x, sine, we can let u equal sine x. And remember last lesson, find the derivative of sine x cos x. We rearrange for, so dx is by itself. So dx equals du over cos x. I really apologize for this stylus. It is so bad. Okay, so we have cos x. Now because they're minusing, I'm going to split this integral up. I'm going to leave that integral by itself. And I'm going to see how I've split. So it's still the same thing, I've just split it into two integrals. So now I've got cos x dx, and we're going to use this u stuff over here for this second integral. So the sine becomes u squared, the dx becomes du over cos x. So these cos x's cancel out, and we're just finding the integral of u squared. Okay, hopefully that makes sense. So integral of cos x is sine x minus the integral of u squared is u cubed divided by 3 plus c. So the final answer is sine x minus 1/3